Alrighty, so we've seen a warm-up example of using Taylor series, and we reiterated the definition of a Taylor series here and a Maclaurin series here, and now let's just look at interpreting what this is really saying. So let's say you have a generic function f. This graph here is f. Okay, and this is a typo. This should be 1, 2. Not 1, 3. That should be a 2 there. Okay. What can be determined about the coefficients of the first 3 terms in the series? Well, let's think about what the first 3 terms in the series are. The Taylor series is constructed for the function below. What do we know about the first 3 terms? Well, this point here is 1, 2. Okay. Now, the Taylor series centered at 1 is f of 1 times x minus 1 plus the first derivative, f prime of 1. I'm sorry, this should just be f of 1, okay, plus f prime of 1 times x minus 1. And then that's the first term. The second term, the third term here is going to be f double prime, or the second derivative, at 1 times x minus 1 over 2. Okay? And let's see, what do we know about these terms? Well, f of 1 is already given in the problem, so this is simply 2. F prime of 1 times x minus 1. This is the coefficient right here. So this problem here is only asking us about the coefficients. Okay, not really asking us, about what the whole thing, about the entire series is, but just about the coefficients. So first coefficient here is 2. The second coefficient is f prime of 1. Well, what can we infer about this? Well, we can say that, since f of x is increasing, at least from the graph, we know that f prime of 1 must be positive. Okay? So whatever this coefficient is, it must be a positive number, okay, plus something, right? And again, we're not asked to find out what the series is. We're just exploring a little bit to see what is true about these coefficients. The next coefficient here is f double prime of 1 over 2. Well, since f of x is concave up, okay, f double prime of 1 must also be greater than 0. Okay. So one of the things that we can say is that the coefficients of the first 3 terms are all positive. Okay? Coefficients of the first 3 terms are all positive. The coefficient of the first term we know is just f of 1. Second coefficient is going to be f prime of 1. We don't know what it is, but this function is increasing. We could probably draw a tangent line here and take a guess, but we know that it is definitely positive because it's increasing. And f double prime, well, it's concave up, so that's also that also means that the second derivative is positive at that point. Okay, so pretty straightforward example there of just interpreting the Taylor series a little bit. Let's take a look at the next video where we're asked some more specific questions about the Taylor series.